This is Cameron Chai here from Azon.com, and I'm speaking to Mark Bumila from Horiba, and he's going to show us through a couple of their particle size analyzers.
What we're going to talk about now are some newer techniques for particle characterization that are based on digital imaging or image analysis. There are two basic approaches to image analysis. There's static image analysis, where the particles sit on a slide. That is the PSA 300. And then to the right over here, we have dynamic image analysis, which is the Retch cam sizer, where the particles are flowing in front of the cameras where we do the imaging. I'll start here with the static image analyzer, the PSA 300. As we look inside the PSA 300, you're going to see the major components include a microscope, inside in the back, a digital camera, and this is an automated stage where we can move the slide and image the particles sitting on a slide. So we call this static image analysis because the particles are sitting on the slide in a preferred orientation during the measurement. The blue light source you see is the source we use for illuminating particles. From the bottom, we look at transmitted light through the slide to perform the measurement. We'll walk around to the front of the instrument now and we'll initiate a measurement on this for the samples you see sitting on that slide. It's not unusual to have two screens when performing image analysis. On the screen to the right, you see the images of the particles and what's going on with the camera during the measurement. And on the left, we have the actions of what's going on with the system, and at the moment also the recorded results. So if I start a measurement, the first thing the system is going to do down here is move to 3 points on the slide so that we know that all the particles we're going to inspect will be in focus. So we go to a position here, here, and here. We automatically focus at those 3 points, and then we planarize the slide so that everything will be in focus as we perform the measurement. It'll take a few seconds for the system to pass through these steps in order to assure all the particles will be in focus on the slide, and then we will begin the measurement. As we're doing the measurement, what's going to happen is as it looks at each of these images, as it looks at each field, first it's going to separate the background from the particles. That's the thresholding step. Then we're going to define the edges, perform some basic image analysis functions to improve that image, and then once the image is improved, we'll start performing the analysis and assigning different size and shape values to each of the particles that show up in each field that we measure. This particular measurement is just set up to be a quick measurement. It'll probably take about 2 or 3 minutes. We're going to look at 24 fields. We'll probably inspect about 2,000 particles while we do that. And in the end, what we will end up with is the particle size distribution and the particle shape distribution of the particles that we have prepared to sit on that slide. I think what we'll do is come back and look at this measurement after it's complete. What we'll do now is walk over to the cam sizer and we'll show you how we can initiate a measurement using dynamic image analysis. So if I could step over here now, please. So the cam sizer is a dynamic image analysis system. You can probably catch, are these pellets falling off?
Fertilizer pellets.
These are fertilizer pellets, larger granular samples, which are falling down in front of two cameras, a zoom camera and a basic camera, so that we can analyze the images across a broad dynamic range, again, of 30 microns up to 30 millimeters. So here we're performing the measurements using these two cameras, which is a patented system. And again, we're going to take images, separate the particles from the background, process those images. You can see the images on the camera here as they're being processed. So as they're falling in front of the cameras, we're taking these images and assigning size and shape values to each of those particles as they fall through the system. So this is a system giving us size and shape information, in this case of granular material. And this has been used in many different applications where we are interested in particle size, particle shape. Has also been used very successfully to replace sieve analysis with more automated results and also much more information about the sample. This is used largely for powder materials and used for fertilizer industry, used in the pharmaceutical industry, catalysts, glass beads, foods, all kinds of places where we're talking about powders that are up over 30 microns in size.
Okay, you can show how easy it is to measure. Just press the button.
Just a sec. We should have finished our measurement. This measurement is currently still in process. What we're going to do is, you see as it changes from the black background to the blue, we're just performing the image analysis. This is still running through various screens, various fields of view of the particles. That result is now complete. And what you see here is the particle size distribution on a count basis and on a volumetric basis. So what you just saw is in 3 minutes we analyzed 4,000 particles, and this is enough to build up a statistically valid distribution. We're just going to perform a very quick demonstration here to see how easy it is to generate data using dynamic image analysis. I'm going to come over and initiate a measurement in the software. This is the sample we just completed measuring. I'm just going to pour it back into the system before measurement. That's loaded into the hopper, which feeds to the vibrating tray, which is going to collect the sample post-measurement. I click OK. We now automatically adjust the height of the hopper and automatically adjust the vibrating feed rate to optimize the concentration during the measurement. So here we are now, several seconds later, initiating the measurement of this large granular material, which is a catalyst. We're generating data, and now within 3 minutes from now, we will have again generated a statistically valid particle size distribution, particle shape distribution, and have images of these particles for people to understand the agglomeration state or the state of their particles. It's as easy as that.